Hello everyone, my name is Jordan Hernandez and today I'll be going over Demo 4 Learning Target 7e. So what is Learning Target 7e about? Learning Target 7e is about I can use hierarchical designs to achieve more complicated functions. And what hierarchical is that it shows an range according to people or things level of importance or related to such systems. So what we can use that in our logic is that we can have some importance with different logics to create one giant logic as explained here. So an example of one is we'll make a multiplication 4-bit circuit. So before we can start with that, we need to make two different types of circuits. One of them will be related back to 7D, I talked about in Demo 4. So the first one is that we need to make a adder 4 circuit. So as we can start out, we shall make our full adder, which is the C out, the carry out is equal to A with the OR plus B, and then Cn with the OR plus with plus AB. And our sum's going to be A exclusive plus B times exclusive plus C carry in, or the carry in, yeah. And what that will look like is we have A and B right here, and we can see our this carry in, it's going to be this guy right here. And then we have this carry in B, this guy right here, this part of the equation. As we can see, this is our sum, and this is our carry out, with our carry in being also our input. So, since now we got our full adder right here, we can now convert it into a circuit using Logisim Holy. And what that will look like is first we'll have our inputs, and since this is going to be 4 bits, we're going to have both A and B values, but A0, A1, A2, and A3, with B0, B1, B2, and B3 with our inputs. And then for our outputs, they are going to be S0, S1, S2, S3, with our carryout being the S4. Or actually, yes, with S4 being our carryout. So, with our carry in, I know it says an S, but it's supposed to be saying carry in. Our carry in will be starting with 0, and with that in place, we got it like this. So the reason why when I say that the carry out is going to be 0 is that it's going to start with a ground wire, as we can see shown in here. So when we have A0 and B0 into our full adder, we have 0 and so on, but I'll be showing it into my Logisim in a second. So, and then this is what I was talking about with the Holy Logisim thing appearance for our circuits for our full adder. So now we have our adder 4 created, and then if we look back to 7D, we can basically use our 4-bit multiplexer, since our full adder is going to be in 4 bits as well. And then for our entire thing, it's going to be a multiplication 4-bit. So with all of this in case, we convert it into the Holy Logisim thing again, just to make it a little bit more simpler, just to implement it into our A multiplication 4-bit. So what our multiplication 4-bit is now going to look like, with corresponding values of, or with our inputs being A and B, is going to be looking like this. So as we can see, we have our B0, B1, B2, B3 be all through this equation. Then we have A0, A1, A2, and A3, which are our main inputs, with our outputs being all the way at the bottom. And this is supposed to be a multiplication setup. As we can see, we have 3 adders right here, and our mux being right here. So, with that being said, we can now go out here, and I can show you what that looks like. As previously shown from 7D, this is our multiplexer. And this is my full adder as seen before. Our adder 4 is going to be right here, and basically with the equations. Oh, sorry, I forgot my Logisim doesn't work with the poker tool when I'm inside the thing. So if we have A0 and B0 being these two being added up, it's going to be 1. If this was to be power, we would have a leftover input of 1 in here. So what it looks like is now I had to zoom out. It's a little huge. But this is our multiplication. So as we can see, we can mess around with it, and then this is what happens if we have B0, B1, B2 being 1 inputs, with A0 and A1 being 1 inputs. We have 0, 0, 0, 1, 0, 0, 1, 0, 1, which is pretty cool. And then if we keep messing around, so we have our AND gates being right here, which represents our multiplication, and then with our adders being kind of like our transfer data to go through these types of circuits, which we want our inputs and outputs being made. But I hope you guys all enjoy, and I'll see you all next time.